Hello, my dear boys. Welcome all of you to my online physics class. Hope all of you are well by the grace of Almighty. We are starting chapter 10 and the name of this chapter is static electricity. From today, we will try to solve some creative question. Okay, so my dear boys, let's see today's creative question. So my dear boys, this is our today's sample creative question. Okay, and this is the stem of our question. Here you seen that two chairs A and B, the value of this charge is 200 coulomb and the value of this charge B is 400 coulomb, and these two charges is separated and the distance between these two charges is 10 meter. Okay, here we have given that work done to bring a plus 5 coulomb charge from infinity at A and B's electric field is 200 joule and 300 joule respectively. So this is our stem of today's creative question. Now the questions are: question A, write Coulombs law. Question B, in the charged object's electric field, potential will decrease as the distance between unit objects increase. Explain. Question number C, determine acting force between A and B charge. And question number D is, if A and B are, these two charges are connected with a wire, explain the direction of electron flow mathematically. So my dear boys, this is our today's creative question. Now we will try to solve this question step by step. So my dear boys, our question A is, write Coulombs law. So the Coulombs law is the force of attraction or repulsion. Here you must remember that the force between the two charges may be attraction or may be repulsion. If the two charges are in same charge, then the force will be repulsion, and if the charge is opposite, then the force will be attraction. Okay, so the force of attraction or repulsion between two charged bodies in particular medium is directly proportional to the product of the charges and inversely proportional to the square of the distance between them, and the force acts along the straight line connecting them. So this is our Coulombs law. Okay. My dear boys, our question B is, in the charged object electric field, potential will decrease as the distance between unit objects increase. Explain. So the explanation is, in the charged object's electric field, potential will decrease as the distance between unit objects increase, because relation between potential and distance is inversely proportional. As the unit objects go further, their distance increases and so the potential decreases. So, in the charged object electric field, potential will decrease as the distance between unit objects increase. So, my dear boys, now we will calculate question number C. Here the question is, determine acting force between A and B. Okay. So, from our given stem, we have given that S charge Q1 equal to 200 coulomb, B's charge Q2 equal to 400 coulomb, and distance between them is 10 meters. So, acting force F equal to what? We know from Coulombs law, F equal to K Q1 Q2 by D square. Here K is a constant and the value of this constant is 9 into 10 to the power 9 Newton meter square per Coulomb square. Okay. So, putting the value of this constant and putting the value of this all parameter, and after calculating we get the force acting force is 7.2 into 10 to the power 12 Newton. So, we can write that acting force between A and B is 7.2 into 10 to the power 12 Newton. So, this is our solution for question number C. Now, we will calculate question number D. Here, the question is, if A and B are connected with a wire, explain the direction of electron flow mathematically. Okay. So, my dear boys, at the stem we have given that external charge Q equal to plus 5 coulomb. So, to bring Q charge at a point, electric field force needed WA equal to 200 joule. So, AS potential is VA equal to WA by Q equal to 200 by 5. So, we get the potential at point A is 40 volt. Again, to bring Q charge at B points, electrical field force needed WB equal to 300 joule given in the stem. So, B's potential is VV equal to WB by Q equal to 300 by 5 equal to 60 joule. So, from this calculation we get that the potential at point B is more than the potential at point A. So, we can write VB greater than VA. So, we know that the current will flow from higher potential to lower potential. So, according to this law, we can say that the current will flow from B to A, and we also know that the flow of current means the flow of positive charge. So, negative charge will flow in opposite direction of current flow. So, because of the potential B at point B is more than the potential of point A. So, current will flow from B to A, but electron will flow from A to B. So the direction of electron flow is A to B when we will connect these two charges by a wire. Okay. So this is the solution for question number D, and this is all for today. In our next class we will try to solve another creative question. Until then, thank you boys.